Welcome back. We are still on the galvanic cell. This galvanic cell here is set up as shown below. We have got nickel and manganese here. We go to the table of reduction potential. We analyze the cell before we can answer the questions. Let's see what we see in the cell. First, you just have to tell that in the cell you write next to nickel and next to Mn. You go to the table and check what is the electrode potential of nickel, because that will determine whether it will be oxidized or reduced. Nickel in the table, we found that is negative 0, is it 2 point, nickel 0.27, negative 0.27. Manganese Mn, we go to the table and find is negative 1.18. Now which one is the big boss between the two? The one that is greater or closer to 0 will be nickel. Therefore nickel, that's where reduction, nickel half cell load will take place. Therefore this where oxidation will take place, and that's where we will be having then an increase in mass. This side will have a decrease in mass, and then in this one as well, that's where we'll be getting the oxidizing agent. This side will be having reducing agent. If you have to write the reaction, we'll be writing in the nickel the forward reaction, and then this one will be writing the reverse. And we know that nickel will be also the positive electrode, and then this will be the negative electrode. That's the small analysis that you can do. Then once you have analyzed that, then we can deal with the questions that follows now. And also in the cell we can see that Y is a salt bridge. Fine. Now let's answer the questions after their small analysis, which is very important for every question. Before you can attempt it, please analyze first. Write down the function of Y. Y is a salt bridge. Salt bridge has got two functions. The easiest one will be the function of the salt bridge here in the question 8.21 will be just to complete the circuit. Fine. Complete the circuit. And then now in 8.2.2 or here we'll say also it can maintain electrical neutrality. Maintain electrical neutrality. Yeah, welcome back. Let's continue. Question 8.2. In which direction will electrons flow in the external circuit? Remember, electrons are moving from anode to cathode. Anode is where reduction takes place, and cathode is where oxidation takes place. According to our analysis, therefore, nickel is our cathode, and then Mn is the anode. Therefore, it means that electrons now will move from Mn to nickel, because they gave us that option to say choose between the one Ni to Mn or Mn to Ni. The second option will be the correct one, from anode to cathode. 8.2.3, calculate the EMF of the cell. So 4 marks. 8.2.3, we said the formula says the electrode potential of the cell equals the electrode potential of the cathode minus the electrode potential of the anode. So in this case, cathode is nickel, it's having negative 0.27. Anode is Mn, is negative 1.18. Now we use a calculator, then it will be 0.95. Is it 0. This is 18, then plus 1. The calculator, then 18, so be 9, or 0.93. It will be 0.93 volts. That is the EMF of the cell. Next question, that's for 4 marks. Write down the balance equation for the next cell taking place. Remember, for balance equation, we must go for reduction and oxidation half reaction. If you look at this one, nickel is reduced. That's where in the nickel half cell reduction takes place. Therefore, we go and copy the forward reaction in that half cell, which will be 2 electrons forming nickel. And this is 8.2.4. And then also put the one of Mn in the table. Mn, it's if you go to the table and see where is Mn, you can see Mn 2 plus, it's forming plus 2 electrons will form that one, but we are writing the reverse direction. Therefore, Mn will form 2 plus plus. It will be Mn 2 plus plus 2 electrons. Then we balance using electrons. This cancels out, and therefore nickel 2 plus plus Mn will form nickel plus Mn 2 plus. That's our 3 marks. Fine. And then the last question here, they say because of nickel ion is now increased. If it's increased, now they say to us, will the reading on the voltmeter increase, decrease, or remain the same? Remember, the nickel ions is the cathode half cell. So if the higher the concentration of the cathode half cell, the higher the EMF, because our EMF is 0.93 when we start the reaction. That's the EMF. Therefore, when the concentration of this one is higher, then also this one is the highest. When this one decreases, the concentration of this one decreases. Therefore, the two are directly proportional, then meaning that now the smaller the concentration of nickel ions, the smaller the EMF. The higher the concentration of nickel ions, the higher the EMF. Therefore, our answer there for 8.2.5 will be the concentration of nickel ion. If it's increased, the EMF will also increase. Is increased. We're choosing there to say right, increase, decrease, or remains the same. So our answer would be increased. So get 1 mark. I hope it's understood so far. Then we can also even apply that knowledge to get more clarity in other related questions. Thanks for now. Right?